Welcome to Unit 14, Part 2, Disk Scheduling Algorithms. So today we're going to talk about disk scheduling algorithms and the role of the operating system to assist with the pending queue cylinders and optimization to get less back and forth movement of the ARM assembly and optimization for getting to the next amount of data on the disk based on the cylinder number. So here we have these scheduling algorithms, and these are the cylinders. So it would be cylinder 98, 183, 37, 122, etc. And there are 0 to 199 cylinders, and we're going to some different algorithms and compare the results and the total head movement on these different algorithms and what that means by the total head movement, because even though some of them have more head movement, it's not a back and forth kind of head movement. So the different algorithms are first come, first serve, shortest seek time first, scan, look, C-scan, and seek. So let's start with first come, first serve. So again, this is the queue, and the head is at location 53. So then it will move then to 98, then move to 183, back to 37, over to 122, back to 14, back to 124, back to 65, and then move again to 67. So if you were to use the first come, first serve algorithm, meaning you're just going to have these queue of pending cylinders and just move the head and the arm assembly to the correct cylinder using first come, first serve, as you can see, will cause a lot of back and forth movement and a total of 640 cylinders of movement, but not just that it's 640 cylinders, it's also that it's a lot of back and forth movement, and a hard disk is mechanical, and a lot of movement like that can wear on the hard disk. So just to remind you that these are the tracks and cylinders, so what happens in this situation is it's moving back and forth a lot to the next cylinder, and moving a lot, and then you have to also keep in mind that you would have to rotate it then to the correct sector in order to transfer the data. Now another thing is the shortest seek time first. Now this is similar to shortest job first because it could cause starvation. What does that mean? It means that when you're at a current head position, you look through the queue of pending requests and you go to the one that's closest to where you are. There's also a lot of overhead because although we are examining a static pending request list, the list is not always static, it's dynamic. Requests are continually coming in, so each time you get to a new location, like here, you need to then look at your pending request and see which one is closest to where you are, because new requests can come in. But using our same queue that we had from first come, first serve, we can see that you start at 53, 65 is closest, then 67, then 37 is closer than 98, then 14, then 98, 122, 124, 183, and then the total head movement in this situation would be 236 cylinders. And if you were unsure how to calculate the total head movement, you just take here 67 minus 53, and then plus 67 minus 14, plus 183 minus 14. I mean, you're just calculating how many cylinders the head has moved. And shortest seek time first, although it may cause starvation, you can see here that it does have less back and forth movement than first come, first serve, has less total head movement of cylinders than first come, first serve. However, there is the overhead of having to calculate each time which request is closest to your current location. Next we have scan. Scan is like the elevator algorithm in that it just moves back and forth along the disk, and it will just pick up any requests that exists along the way. It'll go all the way to one end and then turn around and go all the way back to the other end. So if we were going to do an exercise on scan, you would need to know the current head position, and you would need to know the position the head was in before this so that you know the direction, because the scan algorithm will service requests in both directions. So in this case, the head, it starts at 53, and the previous request must have been large, it must have been before it was at 53, it must have been larger. And so now it's headed in that direction. So it's going to go all the way in that direction to 0. Then it's going to turn around and head all the way back into the other direction, and continue to service requests and along the way. And if there were more requests, it would just go all the way down here to 199 and turn around and go all the way to the end the other side. So the scan algorithm doesn't have to do any kind of overhead in calculating. It just goes back and forth all the way to the end in both ways. But there will be more head movement because it goes all the way to the end, and so it might have more head movement in the long run, particularly if you have a lot of cylinders. The look algorithm is just like the scan, only instead of going all the way to the end, it only goes to the farthest request at that moment. So if more requests come in when it's on its way back, it's going to have to go back after it gets to the farthest request of that moment, and then it will turn back and head the other way. So there's less head movement, but there is a little more of calculation to check to look and see which is the farthest current request. Then C-scan, also called circular scan, only services in one direction. It only services from the outside to the inside, which makes sense because disks have a lot more information on the outside than they do on the inside. And then when it gets all the way to the inside, it jumps back to the outside. So in this case, it's going to service requests all the way to the inside. 199 is the inside of the disk. Then it's going to make a big jump all the way to the outside, and then service requests again on its way back in. Now this is going to have a total head movement much larger because it has to include the jump. However, the movement is a very smooth movement because it just services requests, then makes a smooth jump out. And it's very different than the kind of jerky back and forth movement that is associated with first come, first serve. And look is the same as circular scan, and it only services from the outside to the inside, only it will not go all the way to the inside. It will only go to the furthest pending request, so it has a little more overhead, but you must also include the jump. So keep in mind, if you're using C-look or C-scan, it only services from the outside to the inside, and if you're using look or scan, you need to know which direction it's heading because it services in both directions. So how do you select an algorithm? Well, there's a lot of different reasons. For shortest seek time first is very common because maybe you don't have a lot of requests, so you're just going to go to the next one that's closest. However, it could cause starvation, and the performance really depends on the type of requests. And so some systems choose to just use scan because there isn't much calculation that has to go on at all. The rotational latency also needs to be taken into consideration because just because you move to the correct cylinder, you still have to rotate the disk to the correct sector and then do the transfer of information. So there are a lot of different reasons for using the different algorithms, and so that's something that you should think about and take a look at your case study and see if your operating system uses any of these algorithms. And thank you very much, and we will be talking more about the kernel I/O subsystem in the next unit.